Geotechnical Engineering Part A, Soil Mechanics Session 8, Shrinkage Limit continued. So let's solve another problem. So in this example number 5, we do have a saturated clay soil. So that's a fine grained soil. Void ratio is zero point 0.7. And a specific gravity of soil. So void ratio E equal to 0.7 and the specific gravity GS is 2.72. If we dry the sample completely, mhm, the void ratio of sample reduced by 10%. So it means if this is E1, E2 is 90% of E1. So E2 is simply 9 times 7.63. So we want to calculate the shrinkage limit for this case. Let's see how to approach this problem. So initially, because in all Atterberg's limit, if you remember, all the Atterberg's inc limits, including liquid limit, plastic limit, shrinkage limit, all of them happen in saturate ratio of 100%. So SR is 1. They are all for fully saturated. Our sample is fully saturated. Mhm. So SR is 1 because that's fully saturated. And if that's fully saturated, it means the formula for, let's make it a bit clean, SR times E is equal to moisture content times specific gravity W times GS. SR is simply 1 and our moisture content is equal to shrinkage limit because the shrinkage limit, plastic limit, liquid limit, all of them are kind of a moisture content. Mhm. So if you rearrange the equation, it just gives you shrinkage limits equal to void ratio over GS. And after drying, let's see what's happened. So after drying, our void ratio is dropped by 10%. So that's, we already calculated, that's 0.63. And SL new is the new, so that's if E1 was zero point 0.7, this is E2, and that's 63. So shrinkage limit in scenario 2 or a new one is 0.63 over GS remains the same, that's specific gravity. And if you calculate that, that's 0.23, that's shrinkage limits. That gives us a shrinkage limit of 0.23%. Let's solve another example, and that's our final example in shrinkage limit, and we'll move to new session. A saturated soil sample, again, this is a saturated grain, fine grained soil, and has initial volume of 90 centimeter cubed with a weight of 202. If the sample dried completely, the volume and weight reduced to 87 centimeter cubed and 167 grams respectively. Calculate shrinkage limit. We have solved a one example in previous video, like just replacement in the formula, and one step further, initial moisture content for the sample. So if you jot down the shrinkage limit equation, it just gives us a shrinkage limit is equal to a initial a mass minus final mass minus initial volume minus final one over mass final, which is 167, 202 minus 167 minus, and that this is rho W, which is 1 gram per centimeter cube. multiplied by 100, it just gives us a shrinkage limit equal to 50. In part B, what is the moisture content? Initial moisture content. Initial moisture content is Wi initial, and that's mass of water over mass of soil. So if we dry out the sample and it gives us a 167, that's a stand for mass final, and that's mass initial. Mass initial is including water, so that's a wet mass minus mass of soil at final because it's completely dried over our weight of mass. That gives us a point to 20 something. So if you multiply it by 100, it just gives you initial moisture content, initial moisture content of almost 21%. Thank you. In next video, we talk about a new topics. Thank you.